Oh, okay.
All right, welcome back. I had to go an entire spring break without making a room of people listen to me, so I can't wait 2 minutes to start class, right? Like, it is true they let me teach in the master's program last night, and we all know that was a mistake, right? So, hi, it's me. I have been referred to variously as Professor Calvin, and also, I think that's pretty much it, actually. Are there any, like, funny names for me? I've been trying to get people to call me Vinny for a while. Is that well, Calvin, right?
Oh. That was my name for 18 years, and it never even occurred to me. That's great.
Yeah.
Well, it's not great, but it's better than fucking Cal. What about the faults?
Yes. I go by Vin Gasolina, which is a close relative of Vin Diesel. That's why I love Vim so much, because it's
Vin Gasolina?
Yeah, instead of Diesel.
Is that like
Vin Diesel, you know,
a...
Fast and Furious.
I know Vin Diesel.
But I love Daddy Yankee's Gasolina. It's my favorite song.
Ah, okay. I was wondering where the A came from. I was like, is that a drag persona?
Could be.
Because it could be.
In a way, every day I do class in drag in different ways. Yes. I read this really interesting article over break about how WWE is drag. And I was like...
Oh, extremely, yes.
Well, I realized I didn't understand it because I didn't know what WWE was. So that made it very, very hard to follow the article. So today, as an elaborate prank, I've decided to give a lecture on patterns and anti-patterns because one of the MSCS students said, I think we should have a class on patterns. And I was like, well, I want you to like me, so you give me good course evals. And then I was like, well, if one of them was bold enough to say it, maybe you all care about design patterns. I don't know if that's true or not. Then I realized that I think the thing that has annoyed me the most in the universe this term is, and not all of you do this, but many of you do this. Every time I ask you to do something to a file, you all open the file and then read the entire thing into memory. And I went out of my way to not teach you about memory allocation, so you can't even do that, right? So then, instead of noticing that I intentionally crafted this class such that you could only do things the proper way with data streaming, all of you rapscallions and you youths, you go on to the accursed generative AI, and you allow the robot to speak in our holy tongue, the holy tongue being C89, right? You allow the robots to speak in our holy tongue, and they tell you to allocate an infinite number of bits, right? And so I have looked at so much code this term that allocates an arbitrary amount of memory for no reason, right? If you're doing base 64 encoding, so I'll stop ranting in a minute. If you're doing base 64 encoding, you never need more than 24 bits of anything for any reason, right? The whole thing happens in 24 bits, right? Yeah, I'm letting you use the entire extra 8 bits up to a uint32 without complaining at all, right? It's when I open up code and I see it and it says Malik, size of file. And it's like that file, there's no law that says that file is finite size. Here's an example of a file in C, standard in, which has been reading continuously since 1969, right? That's not bounded, right? So anyways, I thought I'd rant about that for about 90 minutes, then we can go home. I haven't posted the homework yet because I adopted 2 cats, and one of the cats is living in the room with my desktop computer that has all the solutions in it, and I didn't upload the solutions to GitHub because I don't trust me to set the repository to private, right? So I know that if I configure the authentication correctly, you won't have access to it. But I do not know that I can configure the authentication correctly, yes. So the cats are very scared. So they are in dark places and they do not photograph well right now. One of them is named Ursula. She is 11 years old. Is that right? She's 14 years old and weighs 11 pounds. And she has dental disease, and she's also a fearful kitty, which apparently is now a clinical diagnosis. There's cats that are more scared than other cats. Yes. And yeah, right? Yeah, me, right? Peak relatable. And then the second cat, because Ursula clearly wanted a sister, that's not true at all. We've decided Ursula wants a sister. So we went into the Humane Society and we're like, give me your least adoptable cat and the cat that will get along with that cat the best. And the cat that will get along with that cat the best is named Tortoise, who is from Pendleton, and she's a tortoise shell kitty. And they're not very creative up there in Pendleton. In Pendleton right now, there is one other cat in the shelter named Tortellini, who is also a tortoise. And so I thought we should start calling our cat either Tortilla or Tortabella. But anyways, her name is Tortoise, and she hides in luggage. And she's a tortoiseshell. And so tortoiseshell kitties have a black undercoat, and luggage is like black, brown, or gray, right? So I cannot see her at all. My partner claims that she's been living in her closet for 3 days. I have never seen this cat, right? Now, someone is eating the cat food in the bathroom, right? And it's probably not me because I'm vegan, right? Yeah, right? Yeah, just like the cats, right? So anyways, there will be cat pictures perhaps by the end of the semester. Anyways, I laid under my bed, which was extremely uncomfortable, for about 45 minutes this morning, scratching a cat's chin that doesn't care about me at all. And no good photos came from that. So anyways, while I was doing that, what I was not doing was posting the most recent homework. So that'll be assigned on Thursday, I guess, but in theory, we're all still supposed to be working on big RSA. Now, those of you that want to work ahead a little bit, the publicly visible crypto repo has the starter files for the next homework assignment, which is called list_t. And I'm going to ask you to implement a list. Some of you implemented a version of a list in this class previously. It is the same assignment as the plist, CS271. Fortunately for us, there are two satisfying solutions to the assignment, one that uses linked lists and one that uses array lists, and it is unlikely you did both of them. So if this is your second time doing the assignment, use the other implementation. If this is the first time doing the assignment, make your own design decision which implementation you're going to use. I would never voluntarily implement an array list, even though I understand in theory they are high performance. The list T assignment is meant to give you something that you can put the blocks in a blockchain into. So it will store something. And eventually that something will become blocks, but you don't actually have to worry about that yet. So that's what's going on. Let me show you list T real quick so you know where it is. Let's see if I can find it. We've got GitHub, CD C89, crypto. Why did that auto-populate? Also, my new laptop is in. It is currently up in my office reformatting its hard drive because I could not authenticate onto the campus Wi-Fi, and I thought it would be easier to reformat the hard drive than to call WITS. Anyone in here work for WITS? See, put your hand down, Jacob. So you have to make sure Jimmy's not here on some days. Here it is, list T. So this is a lovely thing. I gave you a little make file. I know you all love make files, right? Yeah? Yeah, look at this. Look at this gorgeous little critter here, right? And then, what am I supposed to do? The tester describes what's supposed to happen. The list t.h, blah, blah, blah. Here's descriptions. Look at all this documentation. Wow. This is practically a software engineering class. And list.c is unpopulated. I have an example structure here for you, but I should actually delete that. Actually, I'll delete that right now. Okay. Anyways, this thing basically compiles if you turn off all of the flags, and it doesn't compile without the flags because you have a bunch of unused parameters. So you have to edit that. And you can get this and start looking at it. Okay, stream. A quick digression on patterns and anti-patterns. Do you all know what patterns are? Design patterns? Is this a term that exists?
It's like things it's things you do many times and will always do basically the same way every time, like file I/O.
Yeah, that sounds good. Right, like boilerplate, for example. Yeah. It is C-relevant, and it is C-relevant in that it motivates data structures, because data structures are perhaps the highest form of pattern, right? Data structures and algorithms are patterns. I do not think about patterns a lot. Why is that? I am not I really think of the pattern conversation as coming out of Java, the language that had obvious gigantic gaping holes in it, and these things were described as design patterns. There's a book called Design Patterns that identifies 26 design patterns, and it's written about C++. You could argue that the presence of this book is the argument for why I should not teach you C++, right? That book is old, and I think it describes C++ 99. There have been 2 new C++ standards since then, and by all accounts, it is now a language that is appropriate for usage in some applications, which is an improvement over what it was initially, which was a language for people that were too lazy to learn C, who had to write C, right? And so now C++ is, I think, a real language. It's most commonly used in CUDA C++ with NVIDIA GPUs. And now, in fact, the trend is going away from that as well, where NVIDIA is preferring Python hookups to its APIs, right? But C++, now a real language, was not when the design pattern conversation started, right? This was the 90s. Language theory was underdeveloped. Functional programming and object-oriented programming were still slugging it out. There was no Python 3. There was no Scala. There was no Kotlin. There was no Swift. There was no Rust. There was no Go. None of the modern languages, right? And it is, in fact, my impression that until that crop of modern languages came up, we all should have been writing C. On the flip side, maybe we never got to modern languages if we didn't have Java for 10 years and learned to not like it, right? So that is what I think of in terms of anti-patterns. Anti-patterns are the reasons that you should write C or a modern language. I do believe that, like many things, this came out of the domain of software engineering and now could perhaps more properly be given to systems engineering. Here's an example of an anti-pattern: having a meeting without an agenda. That's not necessarily software specific, right? That's something that emerged from software engineering, because in software engineering people had meetings and they had them without agendas, and they were like, why are we here? And so the meeting that could have been an email in some ways is an anti-pattern that came out of software engineering. Maybe perhaps comes out of systems engineering, and perhaps now the management science people have claimed it, right? So when we say software engineering, project management, and business process, I really strongly think of this as people that had training in computing started having to do things outside of computers, and they noticed some of the methods that could be done inside of computers could be done outside of the computer. So a lot of network science, a lot of graph theory can be applied to human systems as well. There are common recurring problems. The meeting that could have been an email. And you want to have solutions to these commonly recurring problems. I am going to look at these problems today. Duplication. I combined 2 things, which is deficient encapsulation and broken modularization. And that's sort of in 2 directions. You usually are on a scale that ranges from having not enough encapsulation to having too much encapsulation. Magic numbers, which hopefully we all know about. I'm going to address overthinking briefly, and then I will return to it in a later lecture. We have the big ball of mud / God object thing. Now, when I say God object, you cannot make God objects in C because there's no objects in C, right? This is a C++ specific anti-pattern. But you can still make a big ball of mud, and how do you do that? You don't use header files, right? You write everything in one .c file. And we also have data clumps, which is a C language mandatory anti-pattern, right? So I have an anti-pattern that cannot exist in C and an anti-pattern that must exist in C, right? So I'm going to talk about duplication in terms of the context of streaming. And I think of this very strongly in terms of streaming data. Now, some of you may know this about me, but I am actually a recovering undergraduate computer science major, right? I made terrible mistakes in the past, and I am still trying to atone for them today, right? So I hope you can all learn from mistakes. And when I was an undergraduate CS major, I remember that every time someone told me to do something with a file, I opened that file from the file pointer, and I read that whole file into memory because I perceived it as easier. But for the life of me, even though I retain memories of thinking that was easier and doing it because it was specifically easier, I don't remember why I thought it was easier, right? It's just some anti-pattern that existed in my brain. And then at some point, some of you may have known that I went to graduate school and got an advanced degree in computer science, and I'm a recovering CS graduate student, right? At some point when I was in CS graduate school, I had to open a file that was bigger than fit in memory. And at this point in time, I could no longer read the entire file into memory all at once. So I started writing all of my code with streaming data. Here is another motivation that I think is perhaps interesting to you. Some of you may be aware that there is a data science program at this university, right? I really strongly perceive there being a clear divide in data science methods between static data analysis and streaming data analysis. Professor Jed Rembold often talks about data pipelines. I think the dominant paradigm in data science right now is basically based around Kafka, which is a streaming events platform. It is not the author of the trial, but it is named after the author of the trial. And one way to perceive data science happening on the internet is not that there is a collection of files somewhere over which we want to perform some analysis. It is that there are continuous additions being made to the abstract idea of some files, very similar to standard input for a REPL loop like the Python interpreter, right? And so perhaps it is less natural to think of there being clumps of data out in the real world that actually exist, and more so there's just continuous streams of data coming in, and we should be continually evaluating and updating our assessments of things. This is most prominent in the discipline of machine learning engineering, where we place machine learning in an online context, and the models continually update themselves in relationship to new events, and I think that is unbelievably cool. So I think of that as the modern exascale data application. Let's look at two examples. Some of you may have recently worked on something called base 85. Do you all remember the based term? There's no midterm in this class, right? We only have a based term, yes? Wow, tough crowd today. Did you all get rested up over break?
No.
Yeah, me neither. There's only like 4 weeks left, okay? Just like hang in there, right? Yeah. So here is an example of base 85. One way to have structured or designed, perhaps in the context of a design pattern, the base 85 assignment is that you could have abstracted everything into a print in base 85 function. This function would accept as input 32 bits of data, what we think of as one word, and we don't have to think at all about what it prints, but in practice it's going to print 5 ASCII characters. But we don't care how many, that's not relevant to us. What this means is that in addition to reading from a file, I could just open base 85 and I could type directly into it, and I could get base 85 out the other end. That is possible, that is not against the law, I'm allowed to do that, right? And it makes sense to do that because standard input is itself a form of file. So, if I know that base 85 prints any number of characters for every 4 input bits, then I know that every single 32-bit word is independent. I never have to read more than 32 bits of file data at a time, and I never should read more than 32 bits of file data at a time, because reading those bits isn't free. Sorry, what? Okay. I am going to claim it is bad to do this other ways. This is a strong claim. And the reason this is bad is because someone could ask you to base 85 something that is larger than the size of your hard drive. And absolutely nowhere in the specification of the base 85 assignment did I say you may assume that the file is smaller than 10 gigabytes in size, or even smaller than 10 terabytes in size, right? And I have tried to sort of push on this direction. I asked you all to SHA 256 hash Pride and Prejudice with the assumption that you would understand that that is a relatively large file. But I didn't actually have to ask for Pride and Prejudice. I could have asked for the totality of English language Wikipedia, right? There's no law against me doing that. It's completely reasonable to SHA 256 hash the entirety of English language Wikipedia, right? I think we recall that the SHA 256 hashes, what they could be up to like 2 to the 512 bits in size, or so, some like comically large size, right? And so this is what I perceive as being the pattern for how we should do base 85. And I saw this on some but not all midterms, right? And that's why we're talking about this, because I saw things that annoyed me, and I'm taking out my annoyance on you, the helpless students, who are completely defenseless. You are blameless before God. Yes. Okay. So, wow, I was reading some like theology over break. I don't remember what it was. It was pretty interesting. Do you all know who Oscar Romero is?
Nope.
Recent saint, somewhere in Latin America.
Oh, yeah.
Yeah.
I heard about this guy.
Very interesting person. Anyways, read up on Oscar Romero if you're looking for something to do, right? Okay, so we all love do-while loops, right? Is this a well-formed do-while loop? Of course not. It's missing a semicolon at the end of the conditional, right? That's because no one has ever written a do-while loop, so they don't know how to actually write them, right? But essentially, there's going to be some word of data. We're going to print it in base 85, and we're going to keep going until something changes. And that thing that's going to change is at some point, we're going to run out of bits. Here are the, for me, the pattern and the anti-pattern, right? In both of these cases, I have some file pointer, and I open file text in RR. Then I create local variables. I create word and conditional. We're abstracting conditional. We're not thinking about conditional right now. Conditional is just some abstract idea. And then we print in base 85 word. So how are we going to differentiate these? Well, right now we're not taking the words out of the file in any particular way. And so here are two different ways to do this, and I've tried to make this look wrong, right? If, for example, you want to read all of file.txt into memory, you need a buffer of potentially infinite size. Can I make a buffer of infinite size? Do I have an infinite sized hard drive?
Not to my knowledge.
Do I want an infinite sized hard drive?
Yeah. I would presume so.
No, because it uses an infinite amount of energy and causes the heat death of the universe, which means I can't play Monster Hunter Wilds Title Update 1 when I go home after work.
Not to mention the black hole.
And the black hole, right? But which is apparently not a very good film. Okay, so I have a buffer of infinite size, which causes the heat death of the universe and the death of everything I love. But it also vanquishes my enemies, right? So there's pros and cons here. Like, we don't want to say there's only negatives to the heat death of the universe. I think we should listen to both sides. Okay, and then I still maintain a conditional, and then I create some value I. While I am pursuing the heat death of the universe, it is a simple enough matter to read all of the words up to an infinite number of words into this buffer. The buffer is of size uint32, and so then I can simply just print in base 85 all of the words until I run out of words, right? So conditional is when I run out of words. That is one way to do things, and I would like to reiterate once again that the anti-pattern here is you are causing the heat death of the universe, right? This is high stakes. Now, it is true, I have not given you any files of infinite size, but I would if I could, right? But then I would be responsible for the heat death of the universe, right? In this way, your client is responsible for the heat death of the universe. Here is what I claim to be the pattern, the negation of the anti-pattern. In this pattern, I simply allow the file to exist happily and merrily as a file pointer. I don't think too much about it at all. I have a 32-bit word, and I just read 32 bits at a time, and I print them, and I never read anything more than what I print. I read 4 characters, I print 5. I read 4 characters, and I print 5. And I do this happily and merrily without causing the heat death of the universe. Please stop causing the heat death of the universe, right? And so I perceive this as being, it's tough to say this, because I distinctly remember there being a point in my past where I thought this was harder for some reason, and I don't remember why that is. And it must be that some of you think this is harder, because this looks harder to me to write, and you're still not writing this. So I don't know why this is harder to think about, but it has to be harder to think about in some ways. But I'm perceiving it as easier to think about, and I'm introducing this to you under the context of streaming data as the correct way to deal with files of potentially arbitrary size. The first time I experienced obvious performance problems when I was not using streaming data, the file was in between 4 and 4.5 gigabytes in size. It was not a colossal change in performance. It was a few seconds instead of a few minutes. But wow, you wait a few minutes to load a file like 1 or 2 times, and you completely change the way you write code. Like, you do not go back, right? And in fact, sure, I'll show you my research. Where is it? How's GitHub spelled? First try. Oh, I'm logged in. Is any of this stuff secret? Hope not.
You named something Nerve?
No, I didn't name it that. Someone else named it that.
Okay.
It stands for Naive Educational Risk V Processor. You like hardware, you should look it up. No, it's all caps. Right, here's Mirtha. And Mirtha is named after the Queen of the Willis in some ballet. Hold on. In Giselle, right? Giselle.
Giselle.
They're wheelers, not wheelers, and it's Giselle.
Thank you.
I use that ballet background somewhere.
It's important to have at least one ballet dancer around at all times whenever I'm speaking. Anyways, this is streaming data. You can look at it. It's 71 lines. How does this work? I open a file. Am I reading all of the lines in the file? No, I have a file pointer. You can tell I was unbelievably C-pilled while I was writing this, right? And what is this? I read one line at a time, and I don't read all of the lines. I don't read a potentially infinity gigabyte file into a bunch of lists of strings, which I guess is what you would do if you did read lines. It would give you a list of every single line in the file. That would probably explode your computer or something. I don't know.
Where are your semicolons?
So this is Python.
Oh, very good.
But I want to rewrite it in Go, because it's kind of slow. Anyways, and then, oh, what's this? Let's look at Pico. Oh, that's private. Oh, did you see that one? This one's secret. You're not allowed to see that. Okay. What's this? Oh, do you all remember GitHub Actions? Oh, remember that lecture? That was one of my favorites. I don't know if any of you liked it. What's this? Oh, look, I'm running that script over something, and what is this? I'm generating the output of a file with VVP, which I don't know if any of you know what that is, but you probably don't, right? So I don't know how big this thing is. This thing could be any size, which means if I read the entire thing into memory on someone else's servers, this could crash. Does it crash? No, look at the green check mark, right? Okay. So what I'm claiming is that I'm a brain genius. Okay. We never need local copies if we have independence. Here are the examples we have seen so far this class. We have seen with SHA 256, you can read 512 bytes at a time. I think that caused every single one of your brains to explode. All of you wanted to figure out how many bytes you were going to have left over after the last chunk. That does not matter until you get there. Just keep updating the hash value, right? And then when you're at the end, you're at the end, right? It's sort of like life, right? Okay, base 64, you only need 3 bytes at a time, right? Because there are 4 base 64 characters that correspond to 3 input characters, or I guess we can call them input bytes in that case. Base 85 is the same. It's 4 to 5 instead of 3 to 4. Both these are under 32 bits. And then with RSA, we haven't done chunks of RSA, right? But you necessarily can't encrypt things bigger than n because of the modular base, right? So if you're slicing things up, you need to slice them into sizes smaller than n, right? And those n sizes don't actually necessarily have to fall evenly on a bit or byte boundary, right? It's just, as with base 85, which didn't evenly line up with anything, right? You're just going to be dividing things off. So RSA you can batch at size n. Okay. Oh, yeah, whatever. Research. I wrote the streaming implementation, which is called ROTLCON, which stands for Register Transfer Level DICON. And DICON is the name of the output format I'm creating. It's named after the radish of the same name, right? And also, do you remember when one of you, and I think it was one of you in this classroom, posted ROZLCON in the Discord? Remember, ROZLCON, the Versace Beta win, run so fast and don't know where I'm headed. Anyone? No? Okay. Anyways, I thought ROTLCON kind of sounded like ROZLCON, so I thought that was fun. Okay, so these are both working over testbench.vcd. VCD stands for value change dump. My favorite programming language, Python 3, with the streaming implementation, runs in 0.3 seconds, and everyone else's favorite programming language, Java, without streaming, runs in 14 seconds. So that is a pretty big performance difference. And these are relatively small things. So you can see, what is that? That's 30, no. Is that 3 megabytes? That's 3 megabytes, right? How's WC work? I think the last thing is actually bits, right? So this is probably, that's a kilobyte. That's a megabyte. I bet this is 17 megabytes of read-write. So Python streaming can do 0.3 seconds to do 17 megabytes of data. The VCD files that caused my last streaming problem were 4 gigabyte VCD files, right? So this is meant to accommodate files of that size. Wow, I called Python 3 the world's slowest language? That's so out of pocket. Crazy. Okay. Let's visualize this, because I'm worried that I'm not getting my point across. We all know what files are, so we're not going to act like we don't know what files are. We all know what a file is, right? It's a collection of bits of arbitrary size, right? What do you mean? Why are you making that face?
I'm really tired. I thought you meant the bits themselves were like arbitrary large.
That would be so cool. It's like this one happens to be able to store values up to 48, right? Like not for any reason. Like this is our favorite bit. Like if we only had bits like this, we would be so powerful. Yeah. I'd be like, this one stores exceptionally large values of 1, right?
This one stores really big ones.
So I got 2 files here, and I named them File A and B, and that stands for Alberta and British Columbia. Shout out Canada. Who loves Canada? Can I get an O Canada from the? Does anyone know O Canada?
Eh?
Okay.
I don't know.
Our home and native land, and it's not our native land. We're colonizers, right? I think so. Yeah.
That is the second line of the song.
Remember, Canada is also a settler colony. It just doesn't have its own nuclear weapons. They use ours. Okay, and by ours I mean the United States. I am not affiliated with the United States, but not voluntarily, right? I like to think of myself as living somewhere that is under occupation by the United States, right? So can we imagine Shaw hashing Pride and Prejudice? Can we imagine that? Is that within the scope of our imaginations? So I denoted this as PNP arrow SHA, right? You did this, presumably. We all did the SHA 256 homework, right? Right? Yeah? Yeah? Okay. Okay, lock in. Okay. You can also perhaps imagine doing base 64 encoding of a scalable vector graphic, which I might have an example of right here. No, that's some other kind of graphic, right? But you remember when I showed you the scalable vector graphic from embed resources? This is common in the data science applications. Do you care about this at all?
I understand that's some kind of image file that's useful for some things.
Yeah, scalable vector graphics are infinite precision. Here's one. Oh, here. Let's grab whatever this is. This might be a lot of text.
Let's just grab a random picture from the internet.
What are the odds I'm about to get fired? Oh, thank goodness. What a relief. So anyways, there's all these files like this floating around. I don't know if I have an example of them right now. So how do I think of this? Well, I think of those files as being of arbitrary size. Some of them have really, oh wow, I thought of a lot of words for large, none of which I can say in class. Have uncommonly sized bits, right? Oh, that's not great either. Okay. Get me out. We have to get through another 4 weeks of this class without me saying something that gets me more fired than I already am, which I think is pretty fired. Okay, so we can imagine our file as having bits in it, and those bits have addies, which is short for addresses, right? It's also short for people named Addison and Adele, right? Okay, so our initial bits are 0 indexed because this is a computer science class and we 0 index in here, right? And then perhaps we have our second word, which is 4 indexed because we have words that are of size 4 bytes, and then 8 and so on. So I thought of this as being, we can think of the file as being made up of 32-bit words. And we're going to map that to something else. In between these two files, we place the abstract idea of an executable. For example, the base 64 executable, or perhaps the base 85 executable. Do you all know what bijections are?
Yeah.
Everyone said yes, but like with varying degrees of sarcasm, right? So like I don't know what to think about that. Not to worry. This is what bijections are. So bijections are one-to-one and onto, right? They are not the same thing as injections, but they are as restrictive as injections. So an injective function maps 1 to 1. So 1, 2, and 3 all map to different things, but it is not onto. Nothing maps to y, right? Surjection is the other way. That is an onto function where everything in the set to which we are mapping is mapped. So we go 1 to w and so on. But there's a collision. Oh, both 3 and 4 turn into y. So that is a compression surjection, right? And then there's functions that are the worst, right? They're neither, and no one cares about them. Yes, these are functions. They're relations between sets.
Are the neither ones, isn't that like not a function?
I don't know what
You can do
functions
that
are.
one, You can't do one becoming multiple.
That's a function, yeah.
Oh, I guess I think they're relations.
No,
That's
they're
a
functions.
function.
What's a function?
It's when every input has one output.
Yeah.
Roger. Okay. Wow, there's like a lot of math on this slide. Do I know what all these things mean? Okay, so base 64 is a bijection from numbers from 0 up to 2 to the 32 without containing 2 to the 32, right? Because we can represent the 4-byte words as numerical values. And it bijects onto the set of strings of length 5 over this regular expression. What is this? This is capitals, lowers, numerals, and then there's also plus and slash or divide, because those are the 64 characters that are used, right? 26 plus 26 plus 10 plus 2 is 64, right? So these are our eligible base 64. I guess we can call them digits, right? And so there's a bijection between these two things, right? Just numbers and just strings. So the base 64 encoding of a file bijects files to strings. Now, of course, we can store strings in files, but that just means that we can recursively apply base 64, right? Which, how cool is that? You can base 64 encode the base 64 encoding of something, and then unbase 64 encode it, and it's still base 64 encoded, just in a different direction, right? That's cool. Now that's the kind of stuff that really makes you feel like you're wearing a cool hat, right? I stopped at REI on the way down here to shop for hats, and then I looked at how much money they cost, and then I looked at my salary, and then I got a peanut butter cup instead of a hat. Okay, so we can base 64, but hold on. We're people that have been monitoring this lecture so far, so we're not going to base 64 the entire file all at once. What we realize is we only have to look at one of those 2 to the 32 or smaller numerical values, right? So we're going to do that. Wait, how long have I been talking? Oh my gosh. I've been talking about this for a long time. There's 68 slides today.
Should have been 64.
There should, okay, yeah, sure. Okay.
It's possible that we understand that you should stream your data at this point.
Do you think so?
It's-
Oh, but look how cool this looks. Okay. Ooh. Wow, that's right.
Okay, you did a good job on that. Yeah.
This is cool.
That is cool. Yeah.
Right? I actually kind of just wanted to make this graphic. Let's do it again. I also like that it like jiggles a little bit at the top and bottom because it's auto-centering.
Oh, that's why it does that.
Yeah. I like to call this graphic Jigglypuff. Okay. Shout out Pokemon. Who loves Pokemon? Whose favorite Pokemon is Bulbasaur? No Bulbasaur appreciators.
He's awesome, but there's a lot.
He's awesome, but there's
Like
like
favorite is a high bar.
There's like
Who
at least
likes
600 of them.
Diglett? Who likes? I feel like I should just like slam Pikachu. Any Pikachu appreciators? There's no Ash Ketchums in this class. Okay. This is the anti-pattern. The anti-pattern has a freed going into an infinity buffer going into a base 64. And I'm implying that there's absolutely no reason to do that. This is foundational to the data lakehouse technology that is taking over cloud computing, data lakehouse being spearheaded by Snowflake and Databricks, which are both companies that didn't exist 5 years ago and have over a $10 billion valuation. Someone in this class has applied for an internship at one of these two companies. I don't know how well they're hiring or not, but I suspect that if you get a job in the cloud computing space, people are going to talk to you about data streaming and not doing unnecessarily duplication a lot. I had thought I had already taught you not to unnecessarily duplicate data, and then I read all of your midterms, and so that's why I'm freaking out, right? So this is just a random picture from a blog post, but perhaps you have all heard of Perquet files, right? That's one of the big file types that's used sort of in the cloud clusters, right? And so this is based on an SQL query over a presumably Databricks Spark SQL database maintained on top of Hadoop distributed file system, and all of the various cloud technologies. Look into them, they're interesting. This is a big deal also in this class. Why? Because this is what killed my prime generator. My prime generator committed unnecessary duplication, right? It duplicated large numbers of zeros. To divide 5 by 2, I used 25 kilobytes of space. That's bad. That's wrong. That means that I am a honk silly goose, right? I would go so far as to suggest that I should metaphorically be tarred and feathered, right? Anyways, that's duplication. Don't do it. It's bad. Okay. What are we doing here? Oh, deficient encapsulation. Okay. I sort of snuck them up on you, and we'll talk about them more over time, but I didn't want to do a dedicated day in class on them. You all know about header files, right? So with 496t.h, we specified all of the different function types, and we put them in a file, a header file. We can think of that as being a public API, for example. But we're sort of encapsulating how all of that stuff was handled, right? Now, in my ref RSA solution, I realized that when I was computing RSA, I actually needed one additional big operation, and that was big null, which is what I called the thing that checks to see if things are 0. Because of the way I recommended you implement big RSA, where you have separate key generation and encrypt, decrypt operations, I actually needed big null in 2 different files. This means that I had made a terrible mistake. I either had to update a public API and admit I was wrong about something, which I would never do, right? So I would have to add this to 496t, or I would have to include big null separately in 2 different files, or even worse, I would have to create an entire new API just based around big null. So what did I do? Like a coward, I just wrote big null and I copy-pasted it in between 2 different files, which is the exact anti-pattern I just spent an hour complaining about, right? Duplication. I code duplicated. Now, it is true that this is only 5 lines of code, and a toddler could write it. But, you know, if you have toddlers that can write code, you shouldn't have them do this. You should have them solving real problems, like whether P equals NP, right? So, anyways, this is an example of deficient encapsulation or broken modularization. Either way, you get to decide which one it is. But I had been trying to maintain the abstraction boundary where everything that happens to the big numbers happens in a function that starts with the name big, is written in some other file. I don't have to think about it while I'm doing RSA. I started writing RSA and I needed to be able to tell if these things were 0, and I didn't have a way to do that. And I hated that. I think I also needed to write a big max or a big lesser than. It didn't really matter. I had to have some way of telling which one was bigger than the other, which you can either do by asking what the max is or asking if it's greater than or less than, right? So I failed my encapsulation, and that meant that this public API, which is beautiful, other than the fact that div has 2 arguments, right, because of Euclidean division. Can I get some loud boos for Euclidean division? Oh, it wasn't that loud. Okay, I guess you all love Euclidean division. Yeah, good taste. Me too. It's my favorite flavor of division. And I think of this as, does anyone remember what API stands for? Application Program Interface? Is that what we think?
It's an interface, but it's a different.
Yeah. So I regard big null, which you have from me in the ref RSA solution, as a failure of encapsulation, modularization, and duplication. And so I detected this anti-pattern within my own work, so I'm using it as an example in this class of what not to do. And the obvious solution is that in future years, because I will have finished the RSA implementation before I assign the 496, which I tried to do, right? It took longer than I expected. I'll simply add big null to the requirements, and that'll be that. So at some point in your life, I expect some but not all of you, and I don't know how to predict who will do this or not, to be designing either libraries, software, public APIs, test scripts, perhaps packages. I have a few packages I maintain now just because I use them myself, and it was easiest to just turn them into a package and use the right side of my brain to design the package and the left side of my brain to do the bit crunching on it. And so when you start doing this, you should think very carefully about what you're encapsulating and what not, and make sure that you're providing all of the functionalities you need in case later, for example, you have to change how you're encoding the integers in your 496T, right? You don't want someone to have written a big null that like hacks at it, right? We did respect modularization with respect to the NPZ_T, the multi-precision integer type in the big, in the libgmp, the GNU mixed precision library. Those were successfully encapsulated. We did not look inside of them at all. We only used the public interfaces, right? So we shouldn't have big ops scattered to the 4 winds, which is, I think, how many winds there are, which is odd, because I would not expect the number of winds to be discrete, right? So perhaps that is like an exceptionally small value of 4, or perhaps a large one, right? Here's another example. I previously introduced the notion of print in base 85 having a void return type. That is complete clownery. That is a silly goose maneuver, because print in base 85 is the first function that should realize you're at the end of a file, because it's reading chunks of 32 bits at a time. And if it ever gets back something other than size 32, which could in fact also be of size 0, mind you, what it should do is alert someone to that fact. And so I maintain that in this example of a code that satisfied a pattern, I still have an existing anti-pattern, which is the failure of modularization. Print in base 85 should be responsible not just for printing, but also for returning an exit status.
Wouldn't Freed catch that first?
I could check either one.
Yeah, okay.
Yeah. You could just as well capture this cond here, right? So one of these two things, you need to be capturing the return value of it. In fact, I believe if you compile this with all of the flags I ask, it will not let you compile without Freed's return value being captured, right? So, oh, what is that? Me requiring you to use a bunch of GCC flags as a design pattern? Mind blown. I'm so cool and fun. I have friends. I'm well adjusted. People listen to me tell funny stories at parties and laugh, right? Lots of people like my Instagram posts, and not because they're worried about me, right? I have a family member that actually texts me sometimes and was like, hey, I didn't understand your latest Instagram post. Am I supposed to like it or not? And that's like never what you want to hear from someone you're related to. All right, so these things are bad. Why are they bad? Because they're bad. Okay. So here's another example. I have sent you Big GMP. Have you all found Big GMP?
What?
Have you found Big GMP? Big GMP. It's right here.
I don't have the faintest idea what you mean.
It's Big GMP.
You sent it to us?
Yeah, it's in the assignment description for Big RSA. Oh, did you find it? Yeah, do you like it?
What?
It's awesome. Olivia says it's cool, which means it's cool, right? Thank you. I love it when people vouch for me. So anyways, here's Big GMP, and I don't know how intimidated or scared you are of the code I write, which I have heard often is simultaneously the best and worst code I've ever seen, and I think that is true. But I wrote this by avoiding duplication. And how did I avoid duplication? I used these lambda operations. So you can take a look at this code, but I'm also going to describe to you the methodology behind it. So how does GMP work? This was written by other people, but they gave us a public interface, an API, if you are, and we are able to use that API by using the lgmp command on our C files and including gmp.h. So the way this works from end to end is we declare some variable of mpz_t type. Then we initialize that variable. Now, usually if we have like an int x, we initialize it with single equals assignment. We cannot use single equals assignment with this type. We have to use a built-in function mpz_init. This mpz_init is very similar in 496T to performing the sort of memset calls I call, where I zero out all of the bits in something, right? So we could have just as well written sort of big init, for example. Then, if we want there to be any numerical value inside the MPZ at all, we have to MPZ import somehow. So somehow we're going to provide some numerical information to this MPZT, and then it is going to represent that numerical value. There's a variety of operations we have to do to specify that. After we've done the imports, we're going to perform some operation. We'll abstract that for now. We'll talk about that later. But essentially, we're going to do an MPZ add or an MPZ subtract or something of this nature. When all of that is done, we have an MPZT that represents some numerical value, right? But we have to get that numerical value out of the MPZT into whatever we're expecting, which in my case is always 4,096 bits, right? So we do that with an MPZ export, and then when we're done, we need to MPZ clear those variables. Why do we need to do that? Those variables are using up memory on your system, and we don't want that memory to be used up on our system forever, and we're going to talk about not using up all the memory on your system more over the next 2 weeks. So this is an early example of that. So I have lined these up side by side so you can see how this works with big add. Big add declares two values, and you see it has as the 496T inputs up here, right? So we're going to declare two values. We're going to initialize both of those values. This is a null terminated array. That's what that null is doing there. We're going to import both of the values. We have to do it twice, right, because we have two such values. All of these things are things that I just experimentally verified worked. You can trust them. You can figure them out yourself. So I import two values. I import in0 into m0 and in1 into m1. Then I perform an MPZ add. Then I MPZ export into the sum. That's probably misnamed. Yeah, that says sum and this says C, so this won't actually work. And then we MPZ clear and we have another null terminated array, right? So that is sort of the pattern. Now, if I were me, which I am, I would not necessarily want to write 9 lines of code every single time I add, subtract, multiply, divide, or any other operation. So, to avoid that duplication and avoid that anti-pattern, I got really annoyed looking at big add and big sub. And how do we do this? We implement apply. So, what's going on here? We take basically all of the same things that's going on in big add and big sub, and we factor out the commonalities. Line 7 here is the only line that changes. And what does it change? That's changed to now just be called function. It's not specifically add, subtract, multiply, or divide. And we add one additional argument, which I'm calling function. So we've changed the function type to be more general. We are going to apply some function to some 496Ts. And that is exactly what is going on here. Here I called it lambda instead of apply. It makes more sense to call it apply than lambda. That's just what I ended up calling it. So all of these lines are the same as add, subtract, and multiply. All of these lines are the same as add, subtract, and multiply. Only this line differs, but even the arguments are the same, right? M0, M0, M1, and so on. So how does this work? Well, somehow we have to provide those functions as arguments. And this is the way I've done that. We have MPZ add, MPZ sub, and MPZ mul, which are the different sort of operations. I think I have been accused of being a silly goose, making everything exactly 6 characters long, but in fact, these are all exactly 7 characters long with an underscore in the middle. So I think this is a pretty common thing to do. Now, to actually provide these things as an argument, we have to specify their type. When we have arguments in C, we have to give the type of the arguments. So when we say, for example, if we accept arguments in main, we say int main, int argc, comma, character, star, star, argv. And we have the argument vector, right? This is how we specify the type of a function. The function f returns nothing, and it accepts 3 arguments, an MPZ, an MPZ, and an MPZ. And then we are sort of hand-waving the presence of these consts. We have to provide them to not have a type error. And we're just not going to think about what constant means in C, because I don't think it makes sense for that to be in scope this term. And in fact, the presence of these consts is one of the reasons to not introduce the MPZ type, because I would have to teach you about some of the software engineering aspects of C instead of the cryptography aspects of C. So that's why we've sort of hand-waved all of this. But if we take a look at this end to end, we simply provide the function. It is a void function that takes the 3 MPZs, and then we take the 3 496Ts. We put that all together, and all we have to do, my manual dexterity is taking a hit right now. We do all of the application in here like so, and you can look at the example here, which actually works and runs and verifies correctness. And you don't have to just trust me that this works and runs. I think I prove it, right? There's a workflow that checks this. Look, it works. See? I wouldn't lie to you. No, I would. I didn't lie to you about that. What's the last thing I lied to you about? Has anyone been keeping track?
You said you wouldn't lie to it.
That's true. That's good.
Anyways, this code is correct. I'm sad because I really want to like the C programming language, but there is no way to return a function from a function in the C programming language. And the reason for that is everything we return from a function in the C programming language has to have a fixed size in memory. And we don't know how big functions are going to be in memory. Yes?
What does it even mean to return a function? To return the code that defines the function?
No, because you can't malloc it anywhere.
Like,
You can return a function that's already declared, but you can't make custom functions.
what are
Okay.
we pointing to in memory?
Right, you have to point to some function.
Like the code that defines the function? Or
You can't do either. I love Microsoft Windows. Okay. So we can have, this is how I think of higher order functions working. We can make a function that returns functions. And I always want to be able to do this. And you can't do it in C. But you can do it in Python. And when I found out you could do this in Python, that's when I started liking Python, actually.
why do you want to do this?
Because I can pass this to a distributed computing framework, and then it can apply highly generalized and highly parameterizable functions across a bunch of different files, right? So this is a cloud computing technology. It's also a theoretically interesting technology, right? But the fact C can't do this is why languages like Go and Rust have to exist. Because you need a language that can do this to do high performance stuff in the cloud. And the higher level languages like Python are a little bit too slow, just a little bit too slow. Python's almost fast enough for everything, but there's a few things it's not fast enough for. Anyways, you should all read the MapReduce paper. Probably have to say Google. There it is. Oh, look, it's been cited 15,000 times. That person probably got tenure. Okay, cool. Today, efficient encapsulation. Cool, magic numbers. Who has seen the hit film I Am Number 4?
I've not seen the movie. I read the book though. If it's the
It's
one
based
that-
on a book? That's even worse.
It's kind of like a YA.
I read
Yeah.
several of the I Am Number 4 series.
Yeah, it's like a whole series. I read at least a couple of them.
I got to the point where they met 8, and then I was like, this, and then it got, there were too many number characters, and I couldn't keep them all straight, and that's how it is.
I hate it when my young adult characters are straight. Okay, so
He's hungry out here.
here's an example. Remember I showed this on a previous slide and said this is wrong and then kept going because I was getting bullied into going faster, so I finished lecture today. Anyways, this code is wrong. Why is this code wrong? Because this 4 and this 4 are magic numbers. A wizard made them. And that wizard's name is Professor Calvin, right? So, oh, I could be a wizard. I would be a cool wizard. I would be like friends with the woodland creatures. I would teach computer science.
Co-workers with the installation wizard.
Yeah, I would be the installation wizard.
Or would you be like an uninstallation?
Calvin, what's your Harry Potter
No,
house?
absolutely not.
Yeah, Harry Potter's banned, sorry.
What is it?
I'm a Slytherin.
No, you're not.
Yeah.
No, I am. I took the quiz so many times and I got Slytherin. And then my roommate and I, we took it together trying to get Gryffindor. And we still got Slytherin when we were trying to get Gryffindor and we were lying. That we were like,
That's why.
we are apex Slytherins. Like I am the most Slytherin that has ever slathered, right?
Hey, what the hell did you mean by magic number?
That's a great question. So this magic number is not actually supposed to be a 4. It should never be a 4. Why should it not be a 4? Because this 4 is just referring to how big word is. So instead of typing 4 there, what I should do is I should say, oh, this should be the size of however big word is. Which means that if I change how big word is some other day, then this code will keep working.
Well, if you're writing code for the space station, maybe. For the International Space Station, perhaps. But like, you can make assumptions about the data you're working with, and in fact, you should frequently for performance and space reasons.
But it's like
This is equivalently
basic
performant.
exercise.
Yes, it doesn't change performance. Okay. Well, yeah, I know not to keep it.
Yeah, so this is slightly slower to compile. It is much less likely to cause the space station to explode. And in fact,
Much harder to read.
I would argue it is not harder to read because these 4s are undocumented. So there would need to be a comment here explaining what these 4s are. This is self-documenting code.
No,
But,
it's
like,
not.
None of the code we're writing is on anything real. Like we're not
Yeah.
actually making an application, so we might as well work with like the theoretical stuff.
Yeah.
Yeah,
And also, in fairness to me, I did not write code on the space station, but I did write code that flies something that docks with the space station. And I did write it this way.
So I picked maybe one of the worst metaphors I possibly could.
Yeah, I think you completely clowned yourself there. Anyways, if you really hate me and or the space station, you can also use a define. You can use a macro and have word size and define it like so. Right. Also, this coding style introduced here, it predates standard int. So uint 32Ts are always of size 4, but ints are not always of size 4. So there's a bunch of code floating around in the Gestalt consciousness of Linus Torvalds, our Lord and Savior, right? Prayers up. Anyways, and that code has ints in it from back in the olden days before standard int existed. And so all of that stuff had to have size in it because you didn't know how big things were. And in fact, they can be different sizes from the same C compiler on different physical hardware. How many of you had a Nintendo Entertainment System? I think those things have 8-bit words, right? Right, so you have to do size of int on those to know how big your words are, right? So if you're writing a ROM emulator, because you're trying to set a speedrunning world record on Super Mario Brothers 3, you better be using size of, or the space station will crash. Here's a good reason to do this. Some of you wrote 496T, so did I. And when I was done writing it, I was like, dang, wish I wrote 8192T. And I changed these 4 characters, and then it worked.
That's pretty cool.
Yeah, that's awesome. I am extremely cool. Separately, while I was writing 496T, I actually just wrote and test everything at 512 size because it fit on one screen. It was dramatically easier to write and test. It was way faster. So I just wrote 512 and then extended it, and it worked. That's magic numbers. They're magic. A wizard did it. By the way, all this stuff is just bits, so stop overthinking it. There's no ints, there's no strings, there's nothing else. They're just bits. You don't believe me? I know you don't believe me. You'll never believe me. What's going on here? What's this? What's this? Oh, we have a buff. We have a buff. Oh, the buff is full of high. How many characters is this string? Try again. 4. Why is there 4 characters there? The null terminator. Someone said the null terminator. Shout out whoever said the null terminator. Right? The null terminator is my favorite Terminator film. It's directed by James Cameron, who does not understand art. So we can print the buff as a string. We can print the buff as an integer. That's this integer. We can print it as an unsigned integer, and the sign doesn't change because the highest order bit's not set because all of the ASCII values are 127 or smaller. We can also print it in hexadecimal, and it looks quite similar. And then we can also print it as array in both decimal and hexadecimal, right? So these are the ASCII number characters. And oh, look, it's the null terminators. Look at them. They're there. Look at our beautiful bouncing baby null terminators, right? Oh, they're so cute. Okay. These are not numbers. They are not strings. They are not signed values. They are not unsigned values. They are just bits. Do not think of them as something other than bits. The bits will try and trick you into thinking there are signed values, right? Do not fall for it. Because starting on Thursday, sometimes they're also going to be addresses. And that's even weirder, right? So they're just bits. They're just bits. Once bitten, twice shy? Yeah? Okay, all right. I'll keep working on it. You can add 10 to the string, and you get rye. So this is really waiting for Rihanna's next album, presumably, is what's going on here, right? But if we look at this, we see, we increased by 10. And this is in response, partial response to a student's question in the MSCS program up in Portland. They're like, wait, if I add 10 to this, isn't it going to increase the first array location? Yes, it does. See, the first array location increases by 10. But it is this digit of the full numeral that increases by 10. Because the way we print out arrays and the way we print out numbers are in opposite orders. We put the smallest values last when we're printing out numbers, and we put the smallest values first when we're printing out arrays, because this is array index 0. And this is array index 1. So no, it's not weird. It's just bits. Stop.
I don't think those are mutually exclusive.
No,
I think
it's not
just
weird.
bits and weird.
It's not weird.
Okay.
It's normal.
I feel like if the oracle was really unpersuasive and just kind of had to browbeat me out.
Isn't that? I mean, that's kind of what happened. Wow, I saw the Matrix on a list of art made by conservatives the other day, and I perished. I passed away.
I'm not sure that's true.
I am a zombie now. I crave brains. The bits are only given meaning by the programmer. So what does this magic number mean? It's based on the either NSYNC or Backstreet Boys song that goes bye, 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 right? Is that? No? Okay, all right, we'll keep it moving. All right, let's stop overthinking. Big ball of mud. Okay. Big ball of mud and God objects. God objects is the most common anti-pattern I'm aware of. I've taught this class previously, and we did a Mandelbrot assignment. And for years and years, the reference Mandelbrot implementation was a C++ library that contained exactly one object, and every single line of code was written inside the object. There was no reason for it to be an object at all. And that's why I hate C++. That's the one that caused me to finally snap. Anyways, there's this actual existing human called Peter Norvig, and I didn't just select someone whose last name was 6 characters. So do not accuse me of that. Anyways, this person knows the greatest of all programming language, Lisp processing. Lisp, right? We love Lisp. Everyone loves Lisp in this class, right? We're all Lisp programmers. I hope you're all suggestible. So anyways, the famous the famous design patterns book. Most of those design patterns do not and cannot exist in Lisp because Lisp is a well-designed language. So you don't make the design decisions that lead to a lot of duplication or issues of file streaming or issues of magic numbers, right? It is a heavy macros-oriented language, and these things, what we now call higher-order functions, were called macros when Lisp came out. The notion of higher-order functions, that term didn't really exist yet. So Lisp was oriented around that. So what that means is that many anti-patterns cannot exist in certain forms of languages, and one of those examples is the God object. You cannot write an object and put all of the code in an object in C because C will not let you write an object. It protects you from making that mistake. Good job, C. The closest equivalent, I think, is that you cannot use a file structure, right? So if you copy-pasted all of your 496t.c code directly into RSA, that would be bad in some like broad high-level sense, and that would be a god.c file. But Personally, I think every .c file is godly, so that's no problem for me. Lisp is this like highly regarded language that's it was a lot more important before Python got a lot of the functional features that has persuaded me Python's a good language. But you can in fact completely implement the Lisp programming language in the C preprocessor using defines, and people have done this. Let's just move on before we think about that too much. But yes, you can write languages in the C processor and have them run before the code compiles. You have seen running code to determine results or numerical values or magic numbers before the code compiles because we used magic numbers in SHA-256 and I generated those magic numbers in Python, right? So you can, as a component of your C compilation process, run some other language, get some values and plug them into the C file.
God objects are is that specifically a feature of object-oriented languages, or, okay.
Yeah, so I have largely managed to avoid teaching object-oriented languages, but my understanding is first and second year programmers, when you teach them object-oriented code, they jam everything in one object no matter what, because it is, I would argue, hostile to human thinking to use the object-oriented paradigm, so people rebel against it and they just put everything in one object.
One class.
Yeah. And frequently both one class and one object, right? So a single class and then a single instance of that class, right?
That's gross.
Because all you have to do is plug in a bunch of peer functions as methods into that class, and then it's just functional programming again with a terrible interface.
What is the ball of light?
That's the same thing in a non-object-oriented language, so that is if you put all of your C code in one file and don't have a file system.
Why is that bad?
That's bad because it is more confusing because you don't know where to look for code. So you're just scrolling through big files.
I guess if you have enough code, yeah.
And I would argue big RSA is big enough, it probably shouldn't be one file. I would have struggled to do it in a single file, I think, but I probably could have done it at about the same speed. I only used a couple files. Data clump. After all that, we're going to end early. I have spent an hour extolling the virtues of C. And you should probably all have hated that, right? It's obviously a bad language. That's why it's being replaced. And I think it is true that there was no anticipated challengers to C as recently as 3 years ago. No one knew Rust was actually going to work, right? In fact, we still don't know for sure that Rust will work, but in general, to my knowledge, every single person that can write C and Rust gets hired by $1 trillion company to translate C code into Rust code as fast as they can. And there is an infinite number of jobs doing this because there is more C code than there are humans. And absolutely under no circumstances is an LLM ever going to figure out how to translate C into Rust. That is, we're not at risk of that, right? So, I mean, it's unclear that the humans can even do this, right? And maybe someday there will be enough C and Rust that we can train LLMs, right? But that's probably going to be a decades-long engineering effort from a lot of very smart people that practice a lot, right? And in fact, by the time the LLMs can do that, everyone will be completely done doing this manually and be glad the jobs are going away, right? Here is an example of a mandatory anti-pattern in C, and it is the function type of main. You cannot change the function type of main. It is part of the C language standard. It cannot be altered. I saw a small number of students attempt to alter this on the midterm, and that was odd to me because you cannot do this. You must have this type. Now you can write the character double star different ways. It is common to write it star argv open bracket close bracket. I can't really stop you from doing that. I think that's ugly. But you are forced to do this. Yes, Cass?
What do you mean by function type? Like return value?
Return value and parameter value, the combination.
Have an void name. That works. I think I've done it.
Not with the C89 flags.
Oh, no kidding. Okay.
So in early C, main was less restricted, and the standard has restricted it more over time. It is now required to have an integer return type thanks to C++. Now, it is of strong benefit to us as programmers for our mains to have return types because we are now using make files and we are now using GitHub workflows that are going to check the return value and expect there to be a 0 there. Now, modern C compilers, if you write void on main, they just return 0 for you anyways. And you can verify this by looking at the assembly they generate. And they pop a 0 on the stack right before they turn off, right? Very early days in the relatively immature systems before things like Linux or even Unix were around, right? There was much more bandwidth. But now, in fact, if you compile with all of the compiler flags that I require you to use, you are forced to use this function type. You are not necessarily required to do this in embedded systems programming. You could be working on an embedded system that has different expectations, right? Nevertheless, this is a part of the C89 language standard, which is the language standard we are using in this class. And so this is the only function type that can be given to main, though you can give equivalent function types that treat argv slightly differently. But ultimately, it is going to be a vector of strings. No way around that. This is awful. I really don't think you should do this, and there's a variety of reasons I don't think you should do this, but these things are only meaningful in combination of each other, and they are not combined in an object, they're not combined in a memory structure, they're not combined in anything, and we have a built-in way in C of specifying how long a vector is, which is null termination. You don't believe me? Let me give you an example. I showed this earlier today. This is an example of a null terminated vector, not of strings, not of characters. That is a null terminated vector of MPZTs.
What do we mean by vector here?
We don't mean anything by vector. We mean the abstract linear algebra notion. So it is referring to an array.
Like one of these? No.
Yeah, something with n components.
Okay.
Yeah. So the V stands for vector. You can think of it as an array. You can think of it as a buffer. This is clearly was named, and you can see how old this is. This was named before they were using the term array or buffer. That's why it's called a vector. And in fact, it is a vector, right? It is something with n components. Specifically, it's something with argc components. And C stands for count, right? Now in modern code, we would call that n by convention. So here's a null terminated array in C. We do not pass to MPZ inits the number of MPZs we are going to initialize. We simply null terminate. And this is a pattern because this avoids duplication. We would otherwise have to say MPZ init twice. So I think of null terminated strings. It's not really my favorite thing, but the null terminated vector is in fact a pattern, and it could have existed right here. We could ask our operating system to provide us with a null terminated argument vector. The problem is that cannot be part of the C programming language because everything that is passed to main is defined by the operating system. Now the operating system just so happens to be written in C, right? But there are operating systems that predate the language, and so this interface was designed. This is an interface with a public API, and there is no good way to implement this public API with the C programming language, which I hate. So that's a data clump. That's bad. That's the problem we are going to solve next time. And we're going to solve that using structs and mallocs. I think that's all. Oh, okay. Do you want to end however early it is, or do you want me to talk about P strings for a while?
What are those questions?
Ah, you've bamboozled yourself. Okay. Let's clean this up a little bit. So I think we're probably all familiar with Pascal. It's the character from Nier Automata.
Of the wager fame?
Yeah, probably.
Oh, all right.
And I think a Pascal is like a language, right?
It's also a unit of pressure. And a lizard entangled.
Yeah. So, what is going on with this particular, what I have regarded as an anti-pattern? Let's cast our minds back to the distant past, thinking about the 60s. So in the 60s, there was the beginning of standards around how operating systems interacted with executables. I don't know when the first operating system sprang into existence, but I'm guessing it was in the 60s. I think that's when Unix came into existence, right? And I think that was at AT&T Bell Labs, when computers were things that managed switchboards for phones, things of this nature, right? And one of the competing languages with C at that time was Pascal. And Pascal did not use null-terminated strings. Null-terminated strings have a lot of problems with them. For example, especially in the 60s on slower computers, if you started reading a string, you didn't know how long it was, and you hadn't taken this class, so you didn't know about streaming data. So you caused the heat death of the universe, right? So to avoid accidentally causing the heat death of the universe, another type of string was introduced, and this is called the Pascal string or the P string. So null-terminated strings are often called C strings, and this other type is called the P string. What is the P string? Well, when we take a null-terminated string, if we have, say, 17 characters, we additionally need one further character, the 18th character, which is the null terminator. We'll put that at the end of the string. But we might want to know how long the string is before we get to the end. So in Pascal, the first character of the string is not actually a printing character, it is a length delimiter. So the first character is how long the string is. Now, this leads to one very obvious problem, which is what happens if you have a string of length 256. There's a few solutions, right? Obviously, you could just have a series of concatenated Pascal strings, or if you have a 255, you just check the next one to see if there's a string there. Don't really have a good way to define that interface, right? So Pascal strings lost the string war to null termination, basically. But Pascal strings live on in one very specific case, which is this case right here. This is a Pascal vector. This is a length prefixed vector. Why is that? Well, we can view these two arguments. These two arguments are in some adjacent memory locations when main is called, which means actually we can view this as a single vector, the first or 0th entry of which is this integer type. Now, in 1960, we're all working on 8-bit devices, which means that the characters, the character stars, the character star stars, and the integers are all the same size. So they can all exist in the same vector. So this thing is actually the C language expression of the Pascal language length prefixed vector. And the length prefixed vector is a pattern. It's just a pattern from another language. Now, why do I bring this all up today? Well, soon the list_t assignment is going to go out. And if I were to implement a list_t with what I know right now, I would use both null termination and length prefixing. Because I would create a vector of a certain size, and I would not necessarily use all of the vector at once. I would length prefix it with how much I've currently used, or perhaps with how big it is, and then I would null terminate the other one. So I could, for example, always have a vector of size 256, and if I store 16 things in it, I can prefix it with 256, and then null terminate after the 16th thing to denote that I am at the end of the string. This is one way to deal with implementing a list type in C as an array list. And so I wanted to introduce Pascal strings, or in this case, the more general form, the Pascal vector to you, because the Pascal vector pattern could solve a problem that you may have on the next homework assignment. It is very common in a probably 100 level data structures class that students very often want to store the length of a string in the head of that string. I don't know what causes people to want to do this, but if you are the kind of person that wants to do that, not to worry. Pascal has provided a design pattern that allows you to do that, which is length prefixing strings. Take a look at list_t. I will have the assignment right up presumably by Thursday. We'll see. It's a fun assignment. Don't worry about it too much. And we'll talk a little bit more about memory allocation, structures, and some other things in the next couple of weeks. Actually, what's the stuff that's coming up? Oh yes, blockchain. Yeah, we're learning blockchain next week. So, put all of your money on the blockchain. See you on Thursday. Thank you.